Hello everyone, I'm Siddharthan. This is the 14th project video in our machine learning project series, and in this video we are going to discuss how we can build a machine learning system in Python that can detect whether a person has Parkinson's disease or not. Okay, so this is one of the important projects in machine learning because it comes under healthcare domain. And healthcare is one of those fields where machine learning can contribute a lot. We can use these machine learning techniques to diagnose and find certain diseases early, and when you find those diseases early, treatment can be started soon and that patient's life can be saved. So that is why healthcare projects become very important for us. So in this video, first of all, let's try to understand about this problem statement. So let's understand what is meant by this Parkinson's disease, and what is the procedure we will follow to build this particular machine learning system, and then let's go into the coding part. Okay, so that is the procedure which we will follow in this particular video. Okay, so let's get started. First of all, let's try to understand about this problem statement and what is meant by this Parkinson's disease. Let's say that there is a medical institution, so it can be an hospital or a medical college or a research institute, and they are doing several researches on Parkinson's disease. How you can detect or find Parkinson's disease early, and how you can treat those patients. And using machine learning techniques we can achieve this. And let's say that you are a machine learning expert and this particular research institute approaches you to find a solution for this. Okay, so they want us to build a system that can detect Parkinson's disease in a patient depending on certain medical procedures. Okay, so this is what we are going to see. So let's understand about Parkinson's disease. So Parkinson's disease is a progressive nervous system disorder. So as you know, it is a nervous based disorder that affects movement, leading to shaking, stiffness, and difficulty with walking, balance, and coordination. So Parkinson's symptoms usually begin gradually and get worse over time. So this is the effect that can be caused due to this Parkinson's disease, and it affects mostly people who are more than 50 years of age. So there are also cases when people below that age also get affected with it, and that particular case is called as young onset of Parkinson. So this is one of the critical diseases in healthcare. And let's see how we can build a machine learning system to diagnose this particular disease. Okay, so I'll also explain you more about this particular disease when we go through this video in some other point of time. Okay, so now let's understand the workflow which we are going to follow. The first thing that we need in machine learning is the data which we use to train our machine learning model. So for this we need this Parkinson's data. So the data which contains certain details about patients who has Parkinson's and those patients who doesn't have Parkinson's. So what happens is our machine learning model can find the patterns in this data, and it can understand what are the symptoms can be found in people who have Parkinson's, and what are the symptoms are common in people who doesn't have Parkinson's. So using this data, our machine learning model can detect this particular disease. So we need this data. So once we have this data, we need to process this data. So we cannot feed the raw data to our machine learning model. So we need to do some processing. So once we do the processing, we need to split this data into training data and test data. So this is the general procedure which we follow in every machine learning projects. Okay, so we split this data into training data and testing data, and we use this training data to train our machine learning model. So this is where our machine learning model will understand about the data. Okay, so for this particular project we are going to use a support vector machine model, okay, or a support vector machine classifier. So when we are implementing this model, I will be explaining you in detail how this support vector machine model works. Okay, so once we train this support vector machine model with the training data, we will then evaluate this model to find how this model is working, what is the performance of this model using the test data. So this is the reason why we are splitting the data into training data and testing data. So the training data is used for training the model, and the test data is used for evaluating our model. So once you evaluate your model, we will have a trained support vector machine model. So when you give new data, this particular model can detect whether a person has Parkinson's or not. Okay, whether that person is affected by Parkinson's or he is an healthy person. So this is the workflow which we will follow. So I hope you have understood what are the things we are going to cover in this video. Now let's get into the coding part. Okay, so I will be doing the coding in Python, and for Python programming I will be using this Google Collaboratory. So if you are not aware of this Google Collaboratory, you can just search as Google Colab in Google. So you'll be taken to this collab.research.google site. Okay, so where you can do all the Python programs. Okay, So before starting with the code, I would like to give you a quick intro to my YouTube channel. So you can see, so this is my YouTube channel. So when you open this, you can see this introduction video. So in this YouTube channel, I'm making a project-based machine learning course. So this is the course curriculum video where I have explained about all the videos that I will be covering in this particular channel and all the modules that I will be covering in this channel. So you can go to this playlist section. So from there you can start learning my machine learning course. So when you go to this playlist section, so there will be this created playlist, and second there is this hands-on machine learning course with Python. So I have made videos module wise. So if you are completely new to machine learning as well, you can start learning. So first module is on machine learning basics. Then we have the Python basics that are required for machine learning, and libraries that are required for machine learning, and what is the several data collection and processing steps. So we also have videos on mathematics for machine learning, and there will be machine learning project videos. Okay, so I will be uploading 3 videos per week. So 2 videos will be on this machine learning course order. Okay, so you can download the course curriculum file from this particular video. So I have given the link for the curriculum file, so you can download this file where you can find the details of the videos which I will be covering. Okay, so Monday and Friday I will be uploading videos on this course order, and every Friday okay, so Monday and Wednesday I'll be uploading these videos, and every Friday I will be uploading one machine learning project video. Okay, so you can learn from these playlists if you want to learn this from order. Okay, so if you are new to this Google Collaboratory, you can just go to this second module. Okay, so this module 2, Python basics for machine learning. So in this module I have explained how you can access Google Collaboratory and what are the various features of Google Collaboratory. Okay, so now let's get started with today's video. Okay, so this is where we are going to do all the programmings. Okay, so the first step is to import the dependencies. So in any Python projects, the first step will be to import the dependencies. So I'll make a text here as importing the dependencies. Okay, so the dependencies are nothing but the libraries and the functions which we need for our project. So there are some basic libraries like Numpy and Pandas. So import Numpy as NP. So I'll explain you once I complete this particular cell what is meant by these libraries and what are the functions we are importing. So next we need to import Pandas library, and then let's import from sklearn dot model selection, import train test split, and from sklearn dot preprocessing, import standard scaler from sklearn, import Spm, and finally from sklearn dot metrics, import accuracy score. Okay, just a second. Okay, so these are the libraries. So these are the dependencies that we need. So you can see here we have this NumPy library. So this NumPy library is useful for making arrays. So you would have learned about this arrays in C program and other programming languages. So it is useful for making this NumPy arrays. So we will need these arrays in some point of time in our project. So I have imported this NumPy in the short form as NP. So this is the general convention we use. Okay, and then we have imported the library pandas. So we have imported it as panda PD. So this pandas library is useful for creating pandas data frames. So the data frames are structured tables. So if we have our data in those structured table, we can analyze this data easily and we can process this data easily. And then we have this train test split function. So we have imported this train test split function from this library called as sklearn. sklearn is one of the most important libraries when it comes to machine learning. So it contains several machine learning models and other functions that we need. So from this sklearn.model selection, we have imported train test split. So in the procedure in the workflow, I have explained you that we need to split our data into training data and test data. So for this, we need this train test split function. Okay. And then we have from this sklearn or pre-processing, we have imported this standard scaler. So we have already discussed about this data pre-processing, where we need to process the data before feeding it to our machine learning model. And for this purpose, we will be using a standard scalar function, and this is used to standardize our data in a common range. So you will understand more about this once we implement this. And then from sklearn, we have imported this svm. So svm represents support vector machine. So we are going to use this model, this support vector machine model. And finally, we have this accuracy score, which we have imported from sklearn.metrics. So this is used to evaluate our model. Okay, so it will give us the accuracy score, and it tells us how good our model is. Okay, so in order to run this cell, you can press shift plus enter. So when you press shift plus enter, it will run this cell and go to the next one. Okay, so these are the dependencies that we need. And the next step, so I'll just include another text here. So in this text, you can mention what is the procedures or what is the step you are doing. Okay, so the next part will be data collection and analysis. So we need to collect the data and we need to analyze this data. Okay, so in Google, you can search as Parkinson's disease dataset Kaggle. So this Kaggle is one of the important data science and machine learning sites, and they contain conduct several machine learning competitions, and they also host several machine learning dataset. So we will be using the dataset from Kaggle for our Parkinson's disease detection. Okay, so here you can see this Parkinson's dataset Kaggle. So this is the dataset which we are going to use for our prediction. Okay, so I'll go to the site, and you can see all the various details about this dataset. So this is the dataset which we are going to use. And if you give this arrow, you can see the various details about this dataset. And there is also this, I'll give the citation in the description of this video. So it is this paper is related to this particular dataset. So who have collected this dataset and what are the various features of this dataset, you can find further informations in this paper. Okay, so in order to download this dataset, just go to this parkinsons.data, and you can see this download option here. So you need to download this data. Okay, so this will download our dataset file. So this is a very small dataset. Okay, and you can see this parkinsons.names. So it contains all the details about this dataset. So we don't need this for our machine learning training. So we need this parkinsons.data dataset alone. Okay, so this names is about the details of the dataset. So all the details are given in this particular description. Okay, so you can see who has collected this dataset and what are the various attribute of this dataset and what is the source of this dataset. Okay, so you can see the various information here. So it is composed of a range of biomedical voice measurement. So you can see all the features here. So these are the features which we will be using. So when you train your machine learning model, it will understand the data. So this data, and it can predict whether a person has Parkinson's or not. So let's understand what is meant by this data, what this data represents. So you can see this MDVPFO, and the description of this particular feature is that it is the average vocal frequency, vocal fundamental frequency. So you can come here and you can see there. So it is the biomedical voice measurements from 31 people. So the data we have is voice data. Like several tests will be conducted on these patients. So as this is a nervous based disorder, people will be asked to speak and their speech will be recorded, and several tests will be conducted on it, and various frequency of those voices have been recorded. So we have the average vocal fundamental frequency and maximum vocal frequency and other things, and whether there is any jitters or not. And so we have various features. And then we have this status column. Okay, so in this status column we have health status of people. So this particular status column, so you can see here, so as the value as either 0 or 1. So you can see this value as 1, right? So 1 represents, so this 1, so this 1 represents that that person is affected with Parkinson's. If the value is 0 in the status column, that means that person is healthy. So this is our target variable where we use our machine learning model to predict whether the value will be 1 or 0, where 1 represents that person has Parkinson's and 0 means that person is healthy. So these are the various features of this data set. So if you want to understand how this test works, you can go to this particular paper and you can research on how all this works. Okay, so this is the data set which we are going to use. And let's understand more about this Parkinson's disease. So what happens in Parkinson's is, so it causes degeneration of neurons in the brain, so nerve cells in the brain. So when this degeneration occurs, there will be reduced amount of the chemical in the brain called as dopamine. So when this dopamine amount is reduced in the brain, there several processes will be affected in the body, and people tend to have several movement disorders, like they would have tremors and other difficulty in walking and other things. So you can see all the details here, and this is about Parkinson's disease, and we are going to use this particular machine learning approach to detect whether a person would have Parkinson's disease or not by understanding this particular voice data. Okay, so this is about this Parkinson's data set. So you can go to this site. I'll give the link for this particular site in the description of this video. You can download the data set from here. So you just need to go to this Parkinson's.data. From there, you can click this download option. So your data will be downloaded. Okay, so I'll just close this. So once you download the data, so you can see here it is in the format as Parkinson's.data. So we need to change the extension. So I'll rename this to Parkinson's.csv. Okay, so it will put the data in a CSV file. Okay, so it will be in the form of a CSV file now, because we can load the data in the form of CSV file in a more convenient way. So now what you need to do is, once you change the extension of this data set, so come back to your Google Collaboratory. So you can see this files option here. So as you can see here, I have already uploaded my dataset file, which is Parkinson's.csv. So you can give this upload to session storage option, or you can just right click here and you will find this upload option. So the main thing to note here is you need to change this file to Parkinson's.csv. Before, it will be in the form of Parkinson's.data. Okay, so I have uploaded my dataset file. Now we need to load this CSV file to a Pandas data frame. So we have imported this Pandas library as PD, right? So now let's load this data to a data frame. So I'll just make a comment here as loading the data from CSV file to a Pandas data frame. Okay, so let's create the data frame and name it as Parkinson's data Parkinson's data, and we are going to use this Pandas library. So pd.readcsv. So this readcsv is the function that is present in Pandas library. So inside the code, we need to mention the path of this file. So you can go to this option in this Parkinson's.csv. There you will find this copy path option. So just copy the path and put it inside this code. Okay. So this will load the data from the CSV file to a Pandas data frame. So as I have mentioned you earlier, that data frame is a structured table where we can do data analysis and processing easily. Okay, so this will load the data to this data frame, which is named as Parkinson's data. So if you want to access this particular data frame, you can use this name of this data frame, which is Parkinson's data. Okay, so now let's print the first 5 rows of this data frame and see what are the features we have. So I'll make another comment here as printing the first 5 rows of the data frame. So I'll mention this data frame, which is Parkinson's data dot yet. So this yet function will print the first 5 rows of the data frame. So we have the name of the patient, and then we have all the features. So as we know, these are voice measurements. So we have various frequency of several features, and then we have this status column. So you can see the status here. So in this status column has values either 1 or 0, and 1 represents that person has Parkinson, and 0 represents that person don't have Parkinson. And we have other features. Okay, so we need to separate this status column alone. So let's discuss about it later. So these are the different features we have in our data set. So this yet function to see what is the data you have and what is the range of the data set you have. So you can see as this particular value is in the range of hundreds, and if you go here, so we have this jitter column where the value is very small. It is very less than 0, and so but like basically the data has values in different range. So if you find this, see this spread one column, it has values in the negative range. So we will also discuss how we can rectify this issue and convert all this data in a same range. Okay, so those things will be discussed as we go through this project. Okay, so this is how you can print the first 5 rows of the data frame. Now Let's see how many rows and columns are there in this data set. So number of rows and columns in the data frame. Okay, so mention the data frame name dot shape. So this shape function will give the number of rows and columns that are present in the dataset. So totally we have about 195 data points. So 195 rows and 24 features. So 195 rows means like these data points, and so 24 represents the feature of columns. Okay, so the first name is nothing but the id of persons. Okay, so totally we have 195 rows and 24 columns. So we can get some more information about the dataset. Getting more information about the dataset. So these are the basic things that we do in, when you analyze any dataset. So these are the general things that we do in any dataset that we do. And the next step will be to get more information, and for this mention the data frame name dot info. So this will give some information about the data set. So you can see here, so we have all the column names here, and we have so it tells us how many rows we have and how many columns we have, and non-null values. So count, so null values means missing values. So totally we have 195 entries, and in this particular column we have 195 non-null values. That means no values are missing in any of the columns. Okay, so and this d type gives what is the data type of this values. So there is another method you can use to check whether your dataset contains any missing values. So I'll mention you here how you can find exactly how many missing values are there in each of the columns. Checking for missing values in each column. Okay, so mention the data frame name dot is null dot sum. So this is null dot sum will give us the number of data, missing data or number of missing values in each column. So you can see the values as 0. That means there are no missing values in this data set. So which is a good thing. Now we can proceed with another step. So with the other step. So if you have missing values, we need to process this data. So there are methods like imputation where we use values like mean or median of this data to fill those missing values. So we have already made videos on how you can handle missing values. So that video will be in the fourth module, which is on data collection and processing. So in that playlist, I have made a video where I have explained if you have any missing values, how you can handle those missing values before feeding to a machine learning model. Okay, so as we don't have any missing values here, the next step will be to understand more about this data. So now what we will do is getting some statistical measures about the data. Getting some statistical measures about the data. So Parkinson's data dot describe. So this describe function will give us several statistical measures like mean, what is the percentile values, what is the minimum value. So these are the values which we get. So first is the count. So this count gives the number of values in each column. So we have all the columns here, and this count gives the number of values in each column, and this mean gives the mean value of all the values in that column. So you can see here the mean value of the first column is 154, and second column is 197. If you come to this jitter column, so the mean value is 0.006, and then we have this standard deviation value, what is the minimum value, maximum value, and we have this percentile values. So these are not percentage values, these are percentage. So 25 percentile means in this first column 25 percentage of the values are less than 117.57. 50th percentile means 50 percentage of the values are less than 148 in this first column. So similarly, so these are the various statistical measures we need for our data. Okay, so this particular display function will help us to understand more about our data. So what is the value range of our data and other things. Okay, so if you want to work more on the data analysis part of the data, so it will be very helpful for you. Okay, so the next step is like, let's check what is the distribution of Parkinson's in this data. So as I've told you earlier, so we have this status column, right? So we need to check how many values are 1 and how many values are 0 in this data set. So 1 represents people with Parkinson's, and 0 represents person who doesn't have Parkinson's, healthy people. Okay, so let's check it. Distribution. So distribution of target variable, or in this case it is distribution of target. So in this particular data set, the target variable is nothing but the status. So this status will be our target variable because we are going to predict whether that person is healthy or not, right? So this becomes our target variable. So Parkinson's data, and inside the square bracket we need to mention the column name. So we know that the column name is status dot value counts. So this will tell us the distribution of people with Parkinson's and who doesn't have Parkinson's in this data. So in our data set, so we have about 147 data points, and 147 data points are those people who have Parkinson's disease, and 0 represents healthy people. So in this 195 data points, 48 people doesn't have Parkinson's. So this is the distribution of the data. I'll just make a text here. So we know that 0 means people with Parkinson's. So I'll just name this as Parkinson's positive, and 0 represent, okay, sorry, so 1 means Parkinson's positive and 0 means that that person doesn't have Parkinson's. So let us name that as healthy. Okay, so 0 means that person is healthy and he or she doesn't have Parkinson's disease. So we know this because, so this was mentioned in our Kaggle data set. So it has been mentioned there that if the status value is 1, that means that person has Parkinson, and if the value is 0, that person doesn't have Parkinson. So it was mentioned in that Kaggle description. Okay, so now let's group the data based on this particular status column. Okay, so I'll just make a text here as grouping the data based on the target column or target variable. So target variable is nothing but the status variable or status column. So Parkinson's data dot group by. So we are going to group the values based on this status column, and we are going to take mean of each column. So I'll explain you what we are doing here. So when you run this, we will get this particular output. So we have status as 0 and 1. So we know that 0 represents healthy people and 1 represents Parkinson's people. Okay, so now you can see all the features, and I have found the mean for each cases. So first case is people who doesn't have Parkinson's, and we took all the mean values for people who doesn't have Parkinson's, and we took the mean values for all these columns for people who have Parkinson's. So you can see clear difference between the values here. So Parkinson's people have a very less frequency in this first column. So whereas the healthy people have voice frequency is kind of more in this first column, and you can see the difference in values right in each of the columns. So that means, so there is a clear distinction between people with Parkinson and healthy people. So this difference will be understood by our machine learning model, and it will be used for its future prediction. Say let's consider this example. So once it sees this data, it can know that this is the mean value for this first feature, for this first column for people who doesn't have Parkinson's, and this is the mean value. So if the value is more, then it is more likely that that person is healthy, and if the value is less in this first column, it is more likely that that person is going to be affected by Parkinson's. So this understanding will be found by our machine learning model by itself, so we don't need to mention that. So when you use that machine learning model, it will find that automatically. So this is very important for us. So this is how it can make clear distinction. So when you give new data, it will look at all this data. So if this value is around this, let's say that there is a new value, and this data point doesn't contain this status column. So you can have the status column. So we have the status column, and we need to predict whether the person has Parkinson's or not. So our model will compare the values with these values, and if the value is less, it can probably tell that that person is affected by Parkinson. So this is how this mean value is important for us. Okay, so this is how you can group your data based on the status or based on the target variable using the mean of each columns. Okay, so if you don't get it, just mention in the comments. I'll try to explain you in more detail. Okay, so this is about this group by function, and the next step which we are going to do is data pre-processing. Okay, so we have analyzed our data a bit, Now let's do some data pre-processing. So now what we shall do is, let's separate this status column from our data set. So as I've told you earlier, this status column is our target variable. So we need it separately. So we need all the other columns separately and this status column separately. And also we don't need this ID. So we will also remove this ID because it is not that much significant, the ID of that person. So we will try to remove these two columns, name and status column, and we will try to put this status column alone in a separate variable. Okay, so what we are going to do now is, I'll just mention it here, separating the features and target. So target is nothing but the status column, and feature represents other columns, so other than target. Okay, so I'll create two variables as x and y, and let's take all the features in x and the status column in y. So I'll mention this Parkinson's data and dot drop. So this drop function will drop columns or rows, whichever you want. So we need to drop, in this case I have explained you, we need to drop this name column and status column, right? So let's drop those columns and store it in X. So Parkinson's data dot drop. So we need to mention the parameter columns. So we need to mention certain columns. The first column which we need to drop is name, and the second column which we need to drop is status. Okay, and axis is equal to 0. So whenever you are dropping a column, you need to mention axis is equal to 1. And if you are dropping a particular row, so let's say that you are dropping this particular, so this fifth row, you need to mention the axis is equal to 0. So dropping a column represents axis is equal to 1, and when you're dropping a row, you need to mention axis is equal to 0. So now let's store all this status value in this y. Okay, so mention this Parkinson's data, and inside the square brackets let's put status. Okay, so let's run this. So this will separate all the features and target. So target is nothing but this status column. You can print this x and y and see. So I'll print this x. You can see now we have all the features here, and this x won't contain this status column. Okay, and now you can print this y. So it contains values as either 1 or 0, where 1 represents Parkinson's positive cases and 0 represents people who doesn't have Parkinson's. Okay, so now the next step will be to split our data into training data and test data. So I have already explained to you in the workflow that we need to split our data into training data and test data, where training data will be used to train our machine learning model, and testing data will be used to evaluate our model, to check the performance of our model. So I'll just put a text here as splitting the data to training data and test data. Okay, so for this we need to create four arrays. They are x train, x test, y train, and y test. So I'll explain you what is meant by these four arrays, and for this we are going to use the train test split function. So we have already imported this train test split function from SQL under model selection, so we are going to use this function. So mention it here. So train test split. So inside that we need to mention x and y. So x, y, test size. So these are the parameters that we want. So test size is equal to 0.2, and random state is equal to 2. Okay, so I'll mention you what we are doing here. So we are creating four arrays here: x train, x test, y train, and y test. So we have this x data, right? So x represent all the features. So this x will be splitted into two arrays. So one array is nothing but the training data. So we will split this x into x train and x test. So x train represents the training data features, and x test represents the testing data features. Okay, so that is meant by this x train and x test. And the corresponding labels here, the labels are nothing but this value as either 1 or 0, this status column. So the corresponding labels for all the x train will be stored in y train. Okay, so the values as either 1 or 0. So those values for x train will be stored in y train. So this y will be splitted in the same way this x has been splitted, and all the corresponding labels for this x test will be stored in this y test. Okay, so we are just splitting this x and y. So this x will be split into training data and test data as x train and x test, and the corresponding labels will be splitted into y train and y test. So that is meant by these four arrays, and for this we are using this train test split function. So we won't manually separate this data, but we use this function train test split, which will automatically split this data. And inside this we need to mention x and y. So because we are splitting x and y, right, so I have mentioned this x and y, and here we have this test size as 0 0.2. So 0 0.2 means 20 percentage. So it means we want 20 percentage of data as test data, and 80 percentage of the data as training data. So it is the general amount we take. So for testing data we usually take 10 percentage of data, 20 percentage of the data. So in this case I'll take 20 percentage of data, because we need more data in a training set and we need very less data in a test data. Okay, and there is this random state. So I have mentioned this random state is equal to 2. So this is just like an identity number. So when you use this train test split function, it will split the data in a random way. Okay, so there is no any specific way. And let's say that you want to split the data in the same way that I have splitted the data here. So what happens is, like, if you mention the random state is equal to 2 in your code as well. So let's say that you are practicing this code again, and you have mentioned this random state is equal to 2. So in that case your data will be splitted in the same way that my data is getting splitted. So if you mention this random state is equal to 3 or 4, then your data will be splitted in a different manner. So this is basically to reproduce the code. It is just to split the data in the same way that other person is splitting. So that is the use of this random state. Okay, so let's run this. So this will split our data into training data and test data. And now you can print x train. So first let's check this x dot shape, and next let's print the x train dot shape, and let's print x test dot shape. So it will give us the number of data point in each of these arrays. X test dot shape. Okay, so let's run this. So X is nothing but our original data set. So it contains 195 data points or 195 rows, and the X train is our training data, which contains 80 percentage of 195, which is 156. And totally we have 20 percentage of data, which is 39 in our X test data. So 80 percentage of data goes to our X train and 20 percentage of data goes to our X test. Okay, so this is how you can split your data into training data and test data. Okay, so then next step is data standardization. So I'll mention it here, data standardization. So let's understand what is meant by this data standardization. So you can come to this first 5 rows. So we have printed this first 5 rows here, right? So we have totally about 24 features, and in these 24 features we have removed this name column and this status column. So don't consider those columns. So when you look at the other columns, so this first column has values in the range of 100, and the second column has the values in the range of 150, and if you come to this jitter column, the value is around 0.007, and this range varies, right? So if you take this shimmer column, the value is around 0.5, right? So we need to convert all these values in a common range. So this is all about data standardization, that we want all the data in a same range. But when you do that, the meaning that is conveyed by this values should not change. For this purpose we use this data standardization technique, where all the data will be transformed to a same range, but it won't change the meaning the data conveys. Okay, so that is what we are going to do here. So scalar. So I'll create a variable called a scalar, and we have already imported this standard scalar function from in this importing dependencies cell. So we are going to load this standard scalar function. So this standard scalar function will take all this data and convert them, or it will standardize them. Okay, so I'll take this variable as scalar, and let's load this standard scalar function, standard scalar parenthesis. So you need to mention this parenthesis. So it means we are loading one instance of this standard scalar function to this scalar variable. Now you can use this scalar variable to standardize your data. Okay, so for this we need to mention scalar dot fit. So this fit function will fit all the data. So it will help this standard scalar function to understand how this what is the nature of this data. So once it understands the nature of this data, it can standardize the data without changing the meaning that the data has to tell. Okay, so we cannot just randomly change this data. So that is why we are fitting this data to this standard scalar function. So in this we need to mention xtrain, because we need to standardize this data using this xtrain and transform the data based on this scalar. So I'll run this. So when you fit this xtrain in the scalar, it will understand what is the range of all the values in this xtrain, and it will transform all the values to a common range. Now we can transform this data. So I'll create the variable, same variable as xtrain, and I want to convert this xtrain value as scalar dot transform xtrain. So what I'm doing is, so I have already fitted this data using the scalar function. Now it knows how this data looks. Now we need to transform the data. So when you use this transform function, it will convert all the values in a same range. So we have transformed this xtrain data in this line. Now we need to transform the xtest data as well. So xtest is equal to scalar dot transform xtest. Okay, so here you don't need to fit the data again with xtest, so it is not the correct way to do it. So you just need to fit the data in xtrain alone. So you cannot use scalar dot fit xtest again. So what I'm telling is, you don't need to fit the data with xtest, you just need to fit the data with xtrain alone, because we don't want our machine learning model to look at this test data before. So this is just like a test. So this is like an examination for our model. So we don't need to show this data to our model. So we shouldn't fit the data with xtest. So we should fit the data with this xtrain alone, and using that fit we can transform this xtest data. Okay, so let's run this. Now you can try to print this xtrain and see whether the data has been transformed. So now you can see the values around the range of zero point 0.6, and it is in the range of -1 to +1. So all the values are in that range, whereas in the previous case we have the values in the range of hundreds, 150s, etc. So this is how this standard scalar function will fit the data, and it will transform the data in a similar range. Okay, so in my previous videos I tried to standardize the data before splitting it to training data and testing data. So there is not a very exact rule of whether you should standardize the data before or after splitting the data into training data and test data. So few people prefer to standardize the data before splitting it into training data and test data, and few people prefer it to standardize it after splitting it to training data and test data. So both of these methods has their own pros and cons. So in the previous videos I have standardized the data before this particular step. So I just wanted to do the other way around, where we split the data first and then we will standardize the data. Okay, so with that being said, the next part is training our machine learning model. So we know that we will train our machine learning model using this xtrain data, right? So I just make a text here as model training. Okay, so for this we are going to use a support vector machine model, right? So we have already mentioned it. Support vector machine model, support vector machine model. So it is called as SVM. So I'll just explain you quickly how this support vector machine model works. Okay, so I'll just go to this slide, and okay, so let's consider these two axes, and there are two features. So x-axis represents feature 1 and y-axis represents feature 2. So these features are nothing but the column names we have. So totally we have about 22 columns in our data set, right? Just consider there are only two features in a data set. So first feature is feature 1, and the second feature is feature 2. Okay, so there are only two columns in our data set. Now there are several data points in our column. So this feature 1 becomes our x-axis value and feature 2 becomes our y-axis value. So let's say that we try to plot all the values. So when you plot the values, so these are the data points that we get. So you can see that there is a clear distinction between this set of data points and this set of data points, right? So when you try to feed this particular data to a support vector machine, what happens is it tries to find a separating line between this data point. So this is the main job of this support vector machine model. It will try to find this line that best separate the two set of data. Okay, so in this case we have only two sets of data, right? So one set of data is people with Parkinson's, and the other set of data is people who doesn't have Parkinson's, though it is similar to this particular example. So our support vector machine model will try to find this line, and this line is called as hyperplane. So this hyperplane separate the data points, and we have these two values. So I have mentioned the data points as 1 and 2. So these are the data points which are very close to this hyperplane, right? And these 2 points are called as support vectors. So support vectors are data points that are very close to this hyperplane. If the location of these support vectors change, the hyperplane also changes. So let's say that this is our so we don't have this data point. So consider that we don't have this 1 and 2 data points. So now what happens is, so this will be our data point which is close to the hyperplane, then it will take shape something like this. Okay, so the main thing which you need to understand here is, if the location of the support vectors changes, the hyperplane also changes. So what happens is, so when you give a new data point, it tries to find in which side that new data point belongs. So let's say that this represents the people who doesn't have data points, so sorry, who doesn't have Parkinson's, and the second red set of data points represents people with Parkinson's. So when you give a new data point to this support vector machine model, which is already trained with the data, it will try to check on which set of data that the new data point lies. So by this, it can say whether that person has Parkinson's or not. So this is how a support vector machine model works. And two features are not sufficient in some cases. In some cases we need to take more than two dimensions. So this is an example of three dimension space where we use a support vector machine model. So this green color plane represents the hyperplane. So here hyperplane is just a line because this is a two-dimensional space, whereas here it is in a three dimension. So this is the hyperplane we have. So if we have three features, then you have a three-dimensional plot, and in our case we have about 22 features. Okay, so our support vector machine model will totally have 22 dimensions. So this is how support vector machine model works, where it will try to find the hyperplane that can separate the data points into multiple sets. Okay, so this is how a support vector machine model works. Now let's try to implement this model in our code. So we have already imported this SVM from sklearn.svm, right? So now we need to use this SVM to load our SVM classifier. So I'll create a variable and name it as model. So let's load this SPM model to this particular variable. So mention SPM dot SVC. SVC. Okay. So SVC represents support vector classifier. So the another type is nothing but support vector regressor. Okay. So classifier model just classify the data into classes. Here the two classes are person with Parkinson and person who doesn't have Parkinson. So it just classify the data into two types or three types. A regressor is something that gives particular values. So I'll just explain you with an example. Let's say that based on certain values, we need to predict whether a person is male or female, let's say that. And that becomes a classification problem because we are just classifying into two classes. A regressor is something that will give you a value. Let's say that we want to predict the salary of a person based on certain parameters, based on their work experience and other values. That becomes a regressor problems. So the main thing to note here is, classification problems will just classify the data points into classes, whereas regressor will give you a particular value, so an integer value or a continuous decimal value. So that is the difference between a classifier model and a regressor model. So we can use this support vector machine model for both classification and regression. So in this case we are going to use for classification because we are going to classify the patients into Parkinson's positive patients and Parkinson's negative patients. Okay, so I have loaded this support vector classifier to this model variable. Now we need to feed our data to our support vector machine model. So this step is training the SPM model with training data. Okay. So we need to use this model variable. So model dot fit. So model dot fit x train and y train. Okay. So this this fitting is nothing but, so we have seen that x-axis and y-axis, right? So you can see here, so we have tried to plot the data in this particular graph, and we try to find this hyperplane. So this is what happens when you use this fit function, this model.fit function, where our data point will be fitted in our support vector machine model. Okay, so this is the training part. So you can see, okay, so one is missing, so fit is missing, so there is some mistake. I just check what happens here. Okay, so we need to mention one parameter here. So as we see, kernel is linear. So I'll run this. So I missed that parameter. So now you can train your model. So these are the parameters for our support vector classifier. Okay, so this will fit our data points in this model, and we will try to find that hyperplane. Now this training part is done. So the data set which we have is very small. So if you have a very large data set, where when we are dealing with deep learning, we can have data set that contains maybe 10,000 rows, 20,000 rows, or even a number of rows in lakhs. Okay, so those data sets are like very huge, and in that cases the training part will require a lot of time. So this is a very small data set and it doesn't take much time. Okay, so we have successfully trained our support vector machine model with this X train and Y train. So as I hope you know that we have splitted this data into training data, right? So X train represents the training data features, and Y train is the corresponding labels, whether it's 1 or 0. Okay, so we tried to fit this data in this support vector machine model. Now the next step is evaluating our model. Okay, so this is about model evaluation, where in this we will try to find our accuracy score of our model. So how well our model is performing. Accuracy score. Okay, so first let's try to find the accuracy score on training data. Accuracy score on training data. So I'll mention a variable as xtrain prediction, and this xtrain prediction is equal to model dot predict. So I'll explain you what I'm doing here. It will be clear once we complete this. So model dot predict xtrain. Okay, so what I'm doing is, so this model is trained now. Now we can give the features alone. So when you give the features alone and you try to predict, it will tell whether that person has Parkinson's or not. It will give the value as either 1 or 0. Okay, and now we will compare the values predicted by our model with the original values. So the original values is nothing but Y train. So original values which are given in the data set, and this extrain prediction are the values predicted by our model. Now we need to compare these two values. So this will be our training data accuracy. Okay, so training data accuracy is equal to, we need to use the function accuracy score. So we have imported this accuracy score function from this sklearn.metrics, right? So this accuracy score function will tell us how well our model is performing. Accuracy score, we need to compare two things, Y train and X train prediction. So this Y train is nothing but the original value, the original label values, and the X train prediction is nothing but the values predicted by our model. Okay, so let's run this. Now we can print our accuracy score of the model. Accuracy score, accuracy score of training data. Okay, so we need to copy this training data accuracy. So let's run this. So it will give us the accuracy score. So you can see here 0.88. So 0.88 represents 88% accuracy score. That means when you take 100 tests, out of those 100 tests you will get an accuracy of in that 100 test, 88 test will be the correct result. Okay, so the accuracy score of, if the accuracy score is more than 75%, then your model is working fine. So it is the general mark we will take. Here we get about 88%, which is really good. Okay, so out of 100 cases your model can predict correctly for 88 cases. So this is accuracy score for training data. Now let's find the accuracy score on test data. Okay, so I'll just copy this. So as I've told you earlier, the accuracy score on test data is very important. So I'll just change this to X test prediction. and model.predict x test. Okay, now this is for test data accuracy, and accuracy score of y test and x test prediction. Okay, so this is the same thing. So we are just doing the same thing, but we are predicting for X test. Okay, so just copy this next cell also, and this is for the text data prediction. So accuracy score of test data, and it should be test data accuracy. So this will give you the accuracy score on test data. So the accuracy score on test data is around 87%. So there is not much difference between the training data accuracy and test data accuracy. So now you may get a doubt. So I have already told you that we need to evaluate our model. So we need to find the accuracy score on the test data, but we have found the accuracy score for training data as well, right? So why we are finding this is, in both the cases, the model should have almost the same accuracy score. So you can see here the accuracy score in this case is 88, and in this case it is 87. So it is almost equal. So if there is a huge difference between the accuracy score on training data and testing data, that means our model has overtrained, or what we call as overfitting or underfitting. So this is one of the problems that we face in machine learning and deep learning. In overfitting, the model try to learn more from the training data. So that is a problem. So I mean, we cannot dive deep into the overfitting and underfitting in this particular video. I just make a standalone video in my machine learning course, what is meant by this overfitting and underfitting, and how you can overcome this overfitting and underfitting problems. The main thing which you need to take note here is, if the value of accuracy score of training data is more, and if the value of accuracy score of test data is very less, that means our model is overfitted, and we don't want that to happen. So we want the accuracy score in both the cases to be almost similar. So that means our model is working fine. So in this case, we get similar values. That means our model is working really good. Okay, so this is how you can evaluate our model. So we have completed almost everything in this particular project. That is the final step of this project, where we will try to build a predictive system. Okay, so building a predictive system. So far we have analyzed our data, we have processed our data, we have trained our machine learning model, we also evaluate our model. But the next step is very important, where we will use this trained model to make a new prediction. So when you give new values, so let's say that there is a new person who want to check whether that person has Parkinson or not. So when you give all those input data, our model should predict whether that person has Parkinson's or not. So that is what we are going to see in this final step. Okay, so I'll create a list here as input data. Input data is equal to, so let's create a tuple. So tuple is nothing but list of values. Okay, so if you just enclose the values in square bracket, it becomes a list, and if you enclose the values in parenthesis, it becomes a tuple. So you can use anything you want. So let's create this input data. So this input data is the new data for which we need to detect whether that person has Parkinson's or not. Okay, so I'll just go to the data set. Let's take some values. Okay, so this is the data set which we used for our prediction. You can open this with your notepad, and I'll just take some values. So I'll just check this status. Okay, so this is the status value, where it is either 1 or 0, right? So we need to uh, take some values. So here I'll take some values as, okay, so where is the status column? Okay, so this is the status column. So I'll just take these two values, because like there are this 1 and 0 is close, so we can easily locate the data in this entire notepad. So that is the reason. So this value is 1, right? So 1 means that person has Parkinson. So if we feed this data, our machine learning model to should tell us that this person has Parkinson, because the status value is 1. So I'll just copy all the values from here. Okay, so let's copy all the values from this particular row. We know that in this particular row, the status value is 1, right? So let's put all the values in this parenthesis. Okay, so now what we need to do is we need to remove this status value. So this is a status value, right? 1. So 1 represents that person has Parkinson's. So if you remember, we don't have this status column in our training data, so we have deliberately removed this status column from this X, right? So we need to remove this status column because you cannot tell the machine learning model that that person has Parkinson's, right? So we are checking the model. So I'll just remove this one from this input data. Now we can try to predict whether this person, so the data from this person, and check whether the person has Parkinson's or not. So there are few processing which we need to do. So I'll just change this input array. So changing input data to a Numpy array. So now this input data is in the form of tuple. So I just want to change this to a Numpy array. So we have imported this Numpy library as MP, right? So let's create a Numpy array as input data as Numpy array. So because the processing on Numpy array is more efficient and easier, so input data as Numpy array, which is equal to np.asArray np.asArray input data. So what happens is this np.asArray function will convert this tuple to a Numpy array. Okay, so now what we need to do is we need to reshape this array. So the next step will be reshape the Numpy array. Okay, so I'll mention you why we are reshaping the array. So let me first do this. So input data reshape. So input data reshape is equal to input data as Numpy array dot reshape 1 comma minus 1. So why we are reshaping the array is we are just giving one data point, right? So if you don't mention this dot reshape, then our machine learning model will think that we are giving 156 values, because we know that the training data has about 156 rows and 22 columns, right? If you don't mention that reshape is equal to 1 comma minus 1, then the model will be expecting that many number of values. So when you mention this 1 comma minus 1, that means it is like telling our model that I'm just giving the value for one data point and I want you to predict the target variable for this one data point alone. So that is the reason for reshaping. So we are just telling the model that we are just predicting for one data point value. Okay, so that is the reason for reshaping. So now the next step will be to standardize this data. So if you remember, once we splitted our data, we have standardized this data, right? So we cannot give the data as such to our machine learning model now. So we need to standardize the data in the same way. So what you need to do is you need to use this scalar function. So you don't need to fit, you just need to use this transform function. Okay, so this step is about standardizing the data. Standardize the data, and standard data is equal to, we know that we use this scalar function, right? Scalar dot transform input data reshape. Okay, so this will standardize our data. So this input data reshape, and it will store the value to this standard data. Okay, so now the next step will be to fit this to our model. So we have already seen that we can use this predict function to predict the target variable, which is either 1 or 0, using this model.predict function. Now we can make the prediction. So prediction is equal to model.predict standard data. Okay, so this will predict the status value of this particular standard data. So we know that we took the data for a person with Parkinson's disease, because here the status value is 1, right? So our model to predict the value as 1, and it should tell that that person has Parkinson. So that is what we are going to do. So let's try to print the prediction as well. So this will print the value as either 0 or 1. Print prediction. Okay, So let's run this. So this should give the value as 1, right? So let's run this. Now you can see here, this is the value predicted by our model. So it tells that the value is 1. That means the person has Parkinson. So it is predicting correctly, because here the data point which we took from our data set has status value as 1, and our model has correctly predicted it, right? So now I'll just include if condition here. If prediction, so you can see here this prediction is printed in the form of list. So it is not in the form of an integer, it is in the form of list because it is enclosed in the square brackets. So let's take that prediction list. If prediction 0 is equal to 0, then I'll just mention another parenthesis here. If prediction 0 is equal to 0, then I want to print that the person, okay, so 0 means the person don't have Parkinson, right? The person does not have Parkinson's. Okay, so whereas else, sorry, so otherwise I need to print else. Okay, so not that. Else we need to print that the person has Parkinson's. So what we are doing here is, so so we can see here that the prediction is printed in the form of list. So when you mention a list, so here the name of the list is nothing but prediction. So when you mention prediction, the list name, and enclose a value, it means that the first value in this list. So 0 means the first value in the list, and 1 means the second value in the list. So in this case we have only one value, so I'm taking this first value in this list, and if that value is equal to 0, then we need to tell that that person does not have Parkinson's disease, because if the status value is 0, that means the person doesn't have Parkinson. Else the other condition will be the value will be 1. So in that condition we want to print that that person does not have Parkinson. So we are just taking the list and checking the value. If the value is equal to 0, we need to tell the person does not have Parkinson. The other case, the person has Parkinson. So let's run this. So the value is 1 and it is not equal to 0. Now it can tell that that person has Parkinson's. So now you can take, so you can see the next value, the value is 0 here, right? So 0 means that person does not have Parkinson. So let's see whether our model is predicting correctly. So if our model is predicting correctly, that it should tell that it should give the prediction value as 0, and it should tell that that person does not have Parkinson's, right? So I'll just copy all these values, and once we paste this value, I'll just put it in this input data. Now we need to remove the status value because we cannot include it, right? So where is the status value? Okay, so this is the status value. So you can cross check the which column it tries. Okay, so this 0 is the status value. I'll just remove this. Now this prediction should tell the value is 0 and the person does not have Parkinson's. That means our model would predict correctly. So now you can see here the prediction which we got is 0, and it tells that that person does not have Parkinson's disease. So this is how you can make predictive systems that when you give new data, it can tell whether that person has Parkinson's or not. So this is how you can build this predictive system. So I hope you have understood all the things that we have covered in this particular video. So I'll just give you a quick recap of all the things that we have done in this particular project. Okay. So the first step is importing the dependencies, importing all the libraries we need. So we have imported some basic libraries like Numpy and Pandas, and we have imported the functions we need like train, test, split, standard scalar, and we have also imported our support vector machine model, and we have imported this accuracy score for evaluating our model. So the next step is data collection and analysis, and in this I have explained you how you can download this data set from Kaggle, and what are the different features we have in this data set, and what is the effects that are caused by this Parkinson's disease. So I have explained all those things, and the next step we have tried to print the first 5 rows of the data frame and see what are the features we have and what is the range of the values we have in each of the features. Then we have checked the number of rows and columns we have, and we got some more information regarding how many values are there and what is the data type of all the features, and whether there are any missing values using the seasonal function. Then we have used this describe function to check all the statistical measures of the data using this count, mean, standard deviation, etc. Then we have checked the distribution of the two cases. So the one represents Parkinson's positive and zero represents LT persons, right? And then we have grouped the data based on the mean of each features for these two cases. And then we have the next step we did is data pre-processing, where we have separated all the features and the target column, where here the target column is status, and then we have stored it in x and y. After that, we have split our data into training data and test data, and once we split our data, we have standardized our data using this standard scalar function. After that, we have trained our support vector machine model. So in this, I have also explained you briefly how a support vector machine model works. Then we have evaluated our model, and we found that we got really good accuracy score of about 80% in both training data and testing data. And finally, the important step where I have explained you how you can build a predictive system that when you give that input data, it can tell whether the person has Parkinson's or not. So this is all about Parkinson's disease detection using machine learning. So I hope you have understood all the things that we have covered in this video, and that's it for this video. I'll see you in the next video. Thanks for watching.